On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to talk about concavity, and this video is geared towards a visual explanation. I think it's important to talk about what a graph looks like visually in terms of concavity. It's a little bit different than increasing and decreasing functions. And then later on, we will see how to apply calculus to determine concavity. I have two curves here, but we're going to look at several more curves in this video as well. This f of x curve here is a parabola that's opening up. Now, in previous videos, we've discussed where a function is decreasing. For example, from here to here, the function is decreasing, and then the function starts to increase, this red curve here. Now, when we talk about concavity, we talk about two things. We talk about when a function is concave upward and concave downward. And I've used these two colors here to match up with these functions. Concave up, a way to visually think about it, think about the U in concave up, and notice this curve kind of looks like a U. This curve, for its entire domain, which is all real numbers, since it is a parabola, is concave up. This red curve is concave up. Now, this one is concave down. Basically, it's going in the opposite direction. It's not a U shape. That's one way to think about it. But at times, this can change. The concavity can change on a function. I have those same two curves over here in Desmos, but now I'm going to change to a slightly different curve. Check out this cubic function that I have right here. Don't worry so much about what the function is, but what I want you to notice is that we have a upside down U, and then somewhere right around here, the curve changes to a U shape. So we have to be able to find this spot where our concavity changes. And again, somewhere right around here is when it changes from an upside down U, concave down, to a U shape. Now, it's not going to be a perfectly symmetrical U every single time, but notice somewhere in here, it's called an inflection point. That's where the concavity is going to change to concave up. So yes, you can have functions that change from concave down to concave up. We can also have functions where it's going the other way. Check this out. Now we have another cubic function. Yes, I have changed the function itself. Again, don't worry too much about what the function is, but I want you to notice now on the left-hand side here, we have the spot where it looks like a U shape. This is where it's concave up, and it looks like right around 0 is when it changes from a U shape to a upside down U shape. So from here to right about here, we have a function that's concave up, and then from here all the way to here, we have a function that is concave down. And again, the big idea here is to understand visually what it means for a function to be concave up and concave down. A way I always think about it is the U and up. If your curve has a U shape to it, it might not be perfectly symmetric. It's concave up. And then we have an instance where we have an upside down U. That is where we have concave down. And then later on, we will explore trigonometric functions as well. The graph of sine of x, concavity is always changing. If I start right here, from here to about here, it looks like the function has a U shape. That's concave up. Then right around here to here, the function is concave down. Then it switches to concave up, concave down. So I hope these functions that we have seen here, polynomials and even trigonometric functions, and you can apply this to other types of functions such as exponentials and logarithms as well. I hope visually we do understand what it means for a function to be concave up and concave down. If you do, then you are ready to tackle some calculus to find these intervals where a function is concave up and concave down, and also where we can find what's called an inflection point. An inflection point is where the concavity changes. And there you have it, some visual examples of what it means for a function to be concave up and concave down. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.